Okay. I'm going to show you how I've been able to successfully replicate the Don Smith design of over unity high voltage transformers and resonance circuits. Okay, here's the original design as done by, well, I drew it up off the original Don Smith schematics, well, what I've been able to make of them. Your main voltage source would come in off of a 12 volt battery or off of a 120 volt inverter, so this is 120 volts of AC coming into it. Here they have a variac, which is a variable alternating current transformer, so it adjusts the amount of 120 volt alternating current coming into the neon sign transformer. This neon sign transformer transforms the energy from 120 volts at 60 hertz to 10,000 volts at 35 kilohertz of alternating current. So it ups the frequency and the voltage. Then here we have the diode bridge. In this case, he connects one to the ground plate of the neon sign transformer and then to the ground of the earth, and then that would be his negative. Here will be his positive for filling up his inside extended Tesla biflar coil. So inside here is his biflar coil, and then here is his pickup coil or his step down transformer. So these were, on his, they were aluminum wire wound with a center tap, all wound the same direction. He has a small alternating current capacitor placed here on one side just to hold a small charge, I believe, in this coil of the capacitor to help create resonance in the circuit. This is his diode bridge. He just has two diodes rectifying the positive side of the capacitors and charging the capacitors that way. So the capacitors charge through the positive only, and the negative, I'm guessing here, it would be connected to an earth ground. So that would be the negative on the reverse side of the circuit. Okay, and that is how that works. I'm going to go over, so my design is very similar to that. Well, here's one more design that I actually got off of freeenergyinfo.com. This was a schematic that they had given of the Don Smith prototype, although I figured after doing some testing of my own, I figured this circuit may have been just a little bit different from what I have found to be accurate. But in another case, this is my version of the circuit. Okay, here we have our, that is blurry, isn't it? Okay, here we have our 120 volts coming in off of our inline. So this could be coming in off of an inverter from a 12 volt battery source if you wanted to create an over unity device. But in this case, we're just looking to show and test the circuit and show you how it works. So we're using 120 volts incoming. The incoming comes in at about no more than 10 watts. It's about 6 watts at 120 volts. So the amperage is very, very, very minimal on the circuit. It's actually like 0.5 amps. So it's only half an amp. And it goes through our compact light fluorescent circuit. This bumps up the frequency enough to power our flyback transformer. So we took and removed the load from the CFL light, so there's not more powering the light anymore. Now it's powering our CFL flyback. This is from a compact or a cathode ray tube flyback transformer from a old tube television. We have it going into these primary pins here of our flyback. We have tested the flyback to find that this is our negative pin. So our negative out will come to this side of the system. So this will be our negative. And this here is our positive. We have our first capacitor in the circuit, which is a small foil capacitor. Then we have our extended Tesla biflar coil, which I will explain how that works here. This is basically, it's basically a capacitor coil, in the way that it's wound. It's wound like a normal capacitor. Okay, here's your plates. I'll do it on this. This is picture these two being two aluminum foil plates. Okay, these two are two aluminum foil plates, and here we have our connector points. So we have one connector point on here. These can be anything, metal rods or wire or anything that's straightened out. You connect them to the aluminum foil, and on one side, so one goes off this way, and then on the bottom, so these are sheets of aluminum foil. You separate them with a plastic sheeting or some sort of dielectric constant to keep them spaced apart, just like you would in a normal capacitor. So you can see the A, the C, the B, and the D. Those are our connection points for a capacitor. This would be the way that you would like to wind the coil. If you're going to wind it, here's your A and your D. So you would start here and you would just wind the coil around so that they wind on top of each other over and over, and that is how the coil is wound. Then you're going to want to take and make your capacitor, or your spark gap, which is here, will be connected to C and D, so it will actually look like this. So C and D are your spark gap, and that is how it works. And then here will be so that's your extended Tesla biflar coil. That's creating your electromagnetic field. This is your pickup coil for your transformer. This is basically, right now I have it built the exact same way of the Don Smith device, except for the fact that I'm using a lot smaller input current. But we are still achieving over unity, so the device does work in the same way that his was. Okay, here we have a small capacitor on one side. This is just a 1600 volt alternating current capacitor. I don't even know the exact specs, but it's just a little small guy. That little blue guy right over there. So, and then we have our high voltage diodes to rectify our positive. Here again we have it connected the same way that they do on Don Smith's circuit. The center tap of our step down transformer is going to be our negative, so this inside is going to be our bridged negative for our capacitor array, and this is going to be our rectified positive. Over here we have our positive coming in, and so those are our positive. So the incoming is 120 volts at about 5 watts, so that's 0.4 amps, and the output is 500 watts at 0.2 amps. Okay, so there's your circuit. That's how it works. Now we're going to turn it on and show you. Okay, there's our multimeter. It only goes up to 600 volts. So we can only run the system up to about 600 volts, but right now I have it tuned so that it's actually less than that. I'm going to turn the circuit on, and here is our amp meter. This measures the amount of current flowing through the alternating current wire. So this is our 120 volt in, and we are testing the amount of current that the CFL is drawing. So I'm just going to plug it in enough for you to see that, because I can't run the circuit too long, but I can show you. Okay, there we are. So we have it plugged in. We are registering over 400 volts. 400 volts. We are at 0.4 on the incoming. So we're at 0.4 on the outcoming side of it. We are at 0.2. 0.2. Okay, so if we do the math, the outcoming voltage right now that we are getting from the circuit is 460 volts. So before I had it up to 500, so we did 500 times 0.2, which is 100 watts. Right now we're getting, wow, 5 amps of current coming out of the circuit. Okay, anyway, and we are only putting in point. So there's our over unity device. It's coming in from the CFL circuit. It's going through the flyback transformer. It's using this small capacitor as a resonance capacitor. Inside of there is our Tesla bifloor coil. That's our spark gap connected to our points C and points D on the extended Tesla bifloor coil. There's our pickup coil, and there is our rectification diodes, and our center tap is right there, and there's our capacitor array. So we're getting 450 volts. 450 volts at 0.2 amps, so 200 milliamps. But the incoming is only 50 milliamps. So the incoming voltage is 50 milliamps at 120 volts, which is approximately 5 watts, a little over 5 watts. And the out voltage is 450 volts at 0.2 amps, or 200 milliamps, so that is a little less than 100 watts. So that is the Don Smith over unity device. Working prototype. First one.